all of you can start your virtual machine and keep it ready. We will come to the virtual machine after completing some of the concepts, okay? So just to give you a recap of what we have seen so far. In Hadoop, in big data, Hadoop is a name given to combine a file system which is called HDFS, Hadoop file system, and a programming model called MapReduce. These two together is called as Hadoop. HDFS is a file system. It sits on the top of your operating system, and the reason why HDFS is sitting on the top of your operating system is because different people are having different operating systems. It will create heterogeneity, and to make sure that everybody is alike, you have HDFS. And we have installed Cloudera virtual machine onto your laptops, which is containing HDFS, MapReduce, and an old version of Spark together. When you start it, all these things are started. So it is a good time to refer to some of the fundamental basic Unix commands. How will you know what are the processes running on your system? What is a command? ps-ax. How will you know whether Hadoop is running? ps-ax pipe grep. You look for that particular command. These are all basic Unix commands. Just Google it, just to practice it on your virtual machine. Those are the assignments. Another important thing that you should do is, after going home, create an email ID. And that email ID may not be your primary ID. Please create it as, let's say, devrajhadoop@hotmail.com, something like that sort. And send me that particular email ID in our group. The reason is, later what you are going to get is, you will get an email in that email that you are going to give me. And in that particular email, you can see a link to something called piazza.com. Piazza. It is not pizza, just an A in between, piazza.com. And you will be getting this particular email. I will be logging in as an instructor. You will all be logging in as participants. And I will log in as an instructor, and I will show you what you should look for after you get this particular email and you register your email into this. Okay, you have to register your email into this. And when you get this particular email, you should log in, and what you will see is a section called resources. For example, these are all my old batches, and I will just take an example of one batch. And if I go to the resources section of that particular batch, you will see the homework assignments, homework solutions, lecture notes, quick resources, books, everything. All these things I will be sharing through this particular piazza.com. Okay. Some batches I shared directly, some batches I share through this. Okay, so he is looking at very with wide eyes. That you didn't tell me to this, my batch. That's what he's asking. All right. Okay. So it is nothing. All that I have given through either the web link or I will go through this particular thing depending upon the space. My web link is getting exhausted. The space is getting exhausted. That's why I am choosing this particular one. And already I gave you the Hadoop Definitive Guide book through the group. Already I shared to you. It is time to read that particular book. That's a Bible for you. You should have that particular book. And another very important thing that you can do if you're interested and if you are spending time is that, I know that there are all lot of work. There is Audible, but Audible is, anybody who knows what is Audible? What is Audible? Audible is podcasts. What is podcast? Reading a book. What a fantastic idea. Look at that, right? But that is about $7 per month. But that's not, may not be worth for you. So another one that is available is called Stitcher. Stitcher. Okay, Stitcher. With this particular icon, you will see Stitcher, and if you log in, you will see Hadoop and data science and all those things. Connect your car speakers to this particular thing. Whenever you travel, start listening to podcasts. Listen to the fundamental great articles, great seminars that are going on, which will increase your knowledge, what is happening in the industry and all those kind of things. Okay, so those are the things that you should do after going home. So that is about PASA. You don't have to do anything to PASA. Please don't go and create an account in PASA until you get an email, an automated email from me. I will register your name once I get your email to me first. So you have to send me your email, and that email may not be your primary email. Why it is not primary email? You will get all sorts of advertisements and all. Later, for the Twitter example, when we are connecting to the Twitter, we will be using that same email. So we need an email that is to be created for this particular purpose. All right. So those things you please do. And we will come back to the fundamental ideas. So HDFS and MapReduce together is called what do you mean by as Hadoop, right? Now, we have seen what is HDFS, and just to make sure that everybody is in sync, let us do that exercise one more time very quickly so that you are getting the pace. Assume that there is data. The data can be unstructured, structured, or semi-structured. What is the difference? Relational database data, which you see in tables as columns and rows. Actually, you should not call as rows and columns. The official word that you should be taking, nobody tells it, is called a tuple and tuples. And when you call a table, don't use the word table. It's called as a relation. That is the real world of relational database management systems. A relation is nothing but a table. A table contains rows and columns. This is structured data. And why do we call it as structured data? Because you have got columns, you have got rows. It is neatly assigned as you specified. And how did you specify it? In your DDL, you specified it. What is a DDL? Data definition language. In the DDL, you told that create table employee as ename, which is varchar2, and age, integer. You told how your data should be laid out. That's called structured. If you look at an Excel document, if I am giving you the real estate prices as an Excel file, you will just load it. You didn't tell any DDL before you are loading to Excel. If I give you, okay, not real estate prices, but the prices of a particular grocery shop, you will just load it. The first data is completely different from the second data. First data may contain 200 columns, second data may contain 100 columns, but you did not tell anything like a DDL how the data should be laid out. And Excel automatically lays it out for you, semi-structured. It is structured, but it is semi-structured. Or the official term that you will use, we will see it a little bit later, it is too advanced to tell it that. This is called schema on write. This is called schema on read. That's the official term that you should use for that. Alright. Now, there is a third category, image, a PNG file, an MP3 music file, etc. No structure. You cannot load just like that. Those are called unstructured data. Whether you put structured, unstructured, or semi-structured data into your HDFS, HDFS will divide that data into block sizes. And each person is going to get a definitive block. When I say each person, each node in the Hadoop cluster. So, if you consider yourself as nodes, all of you will be sitting in a data center in a rack. So, this is Seiko node, this is a Bhaskar node, this is a Ashwin node, this is a Ruchi node. All you will be sitting in the rack. This racks constitutes a data center, which you call it as enterprise data center. Enterprise data center, if you use a Linux machine, it is called a EDCL. And if you use Hadoop, then depending upon Cloudera or Hortonworks, you will add that acronym for that. Then you will tell whether it is production or staging or development by adding another word, let us say D for development. And then you will have a machine name for that particular thing. Now you understand how the machines are named. This is how in a normal enterprise will name the particular nodes and everything. So these are all nodes. These are all nodes. Nodes are there in the rack. And here comes the power of Hadoop. When you distribute the data into Hadoop, Hadoop will divide the data in such a way that they are close. It won't divide data in this particular node versus another rack somewhere and you node it here. Then the network bandwidth will become a problem. The biggest advantage of big data is solving network bandwidth. Minimum time as possible to collect the data and give you the data. So everything will be distributed. This is also called data locality or data or rack awareness is another term that is being used. So depending upon that, the data will be distributed, and we already know that the default block size of Hadoop is 128 megabytes. And it is too huge. Why it is too huge? Because in Windows or in other systems, when you look at the block size is very small. It varies. Maybe in kilobytes or maybe in simple megabytes, 1 MB, 10 MB like that. So if I have a 1000 MB file and if I use a normal operating system which is dividing the data in KBs, let's say 1 KB, 1000 MB, so it is 10 to the power of 6 KBs, 10 to the power of 6 blocks will be created. To collect the data, there is a rotational delay, there is a disk time. You assume that your old gramophone records where the head is like this and the head is rotating, and that head has to find out which rack my data is, and there is a rotational delay which will happen to pull that particular data. That rotational delay, seek time, etc. will be very, very huge. That is why a SATA disk is better than a SSD, or SSD is better than a SATA, and similarly the other disks are much faster than SSDs. What is the difference? The normal disk, if you have looked, it will look like this, a square box, right? Now you are getting the disk as a RAM. And that's what an SSD is all about. Just like a RAM chip, you can keep it. There is no that old type of disks available. And what they did is the rotational delay and the seek time got reduced. And now you have this particular architecture where you have the small block size constituting large number of files. That will create a huge problem when you are dividing the data. And Hadoop people understood that. That's why they told that, hey, my data size is going to be 128 MB. So 1000 MB divided by 128 MB is near to about 8 or 9 blocks. That's all. Versus 10 to the power of 6 versus 9 blocks. See the efficiency there. And all are closer together. So the read time and everything is going to be faster. So the exercise that we have done is, we had a person who is standing here, okay? And this particular person, let us call him as the controller. And he has got a huge load of goods, 1, 2, 3, 4, 5. He wanted to distribute these goods into some trucks which are standing here. These are all the trucks which are standing here. And he wants to distribute, he or she wants to distribute this particular loads into this particular trucks. Assume that each load is 128 MB, which is the block size. Assume that each truck can contain 128 MB. First block will go here, second block, third block will go here, fifth block will go here. Like that, this controller is going to distribute the data into the trucks. But this controller should know which block or which chunk of data has gone to which truck. So he will maintain a ledger. And in the ledger he will write that, okay, the chunk 1 went to truck 1. So chunk 1, truck 1, chunk 2, truck 2. And to make sure that nobody is stealing it, he will create additional copies of the trucks, where the copy of this particular one, he will create 2 different extra copies. So that if this is lost, this is available. If this and this are lost, this is available. 3 copies. So 1, 2, 3, 4, 5. 5 into 128 will become 5 into 3 into 128 MB. Why? Because it is multiplied 3 times. So everybody will tell that hey, Hadoop is expensive. Why? Because you are creating 3 copies of the data. My 10 GB of data became 30 GB of the data. No, that answer is absolutely wrong. Why? Storage is cheaper. Storage is drastically going down. So nobody cares about storage. Oracle is not going to cost you based upon the storage, but they are going to charge you based upon the CPUs. So, reliability is achieved by creating the copies. And you created all this data. And this controller is called name node in Hadoop. And the trucks are called data nodes. This is the fundamental of Hadoop. So all of you can go to the browser in the virtual machine, open the browser in the virtual machine. There is a browser in the virtual machine, and don't create any trouble. I clearly explained to you what is the difference between a virtual machine and a local system, everything yesterday. Do not open the browser Internet Explorer of your local machine. I want the browser Firefox to be opened in the virtual machine. And go to the URL localhost 50070. Please look at this number. And please by heart that number. That is the next concept. Localhost 50070. What do you see? Localhost 50070. Open the browser. Ravi, in the cloud or a virtual machine, there is a browser. Go to the desktop. There is a browser on the left hand side called Firefox. On the top, I told you terminal yesterday. On the left side of the terminal, there is a browser. Firefox, is it not?
Where's the browser here? Yes.
That is a browser. Click, man. Oh. Opening the browser, I need to teach you. Open the browser. Where is the virtual machine, my dear friend? Open that. The browser is already open for you.
Where was it?
Please apply common sense while you are in the class, okay? Open the browser in the machine. And type localhost 50070. And press enter. Do you know how to go to google.com? Like that, I am telling you, please go to localhost 50070. Type here, yeah. What is this, Devraj?
Yes.
Where you will go to newspaper, reading Telugu newspaper?
Open the tab. Type here. Local.
You're on the correct page.
But this browser was inside the machine.
Yeah.
It is in the virtual machine, no.
Yeah, but where was it on the screen on the bottom?
Pardon?
For you, I think it's by default it came by itself.
Oh,
No. But when I started for you.
The
Virtual
browser.
machine.
Yeah.
Right.
Virtual machine. And by default, the browser is open.
So this was
You can minimize the browser like this. Then you see the virtual machine.
right.
Right? I told you to open the browser if you don't want to, means if there is no
Oh, that's the
default,
browser.
that is the browser. Right? What did you see? And that is giving you this, what you show here. How many name nodes are there? What is the data node? The complete description is available there about the virtual machine. And can you tell me how many name nodes are there in your virtual machine? Only one. How many data nodes are there in your virtual machine? Only one. Is the name node and the data node different? No. Everything is combined together into one single virtual image. That is what we call as the virtual machine. So, please look here now. How the architecture of a real Hadoop cluster will look like. Nodes will be there like this. One of them will be name node, and there can be only one name node in the entire cluster. All these will be the data nodes. This is the admin screen, and this is what the administrator will look. which node is live, which node is not live, etc. Everything it will show you. So remember this port number. By default, whenever you start Hadoop, it will open the statistics about the controller and the data nodes in the port 50070. Now, can anybody call me on Skype who is fast? Come on, it is getting recorded. Seiko, are you clear now? You got how to open the browser?
Yeah,
In the virtual machine. It's completely different from the local.
of course.
Yeah. Now, for those people who are wanting tricks, right? They don't want to work hard and they always want a UI. Don't do that, but I will tell you what it is. Because if I don't tell it, you will tell that it didn't tell at all. There is a link in that particular Firefox browser on the top if you see, which will read as Hue. For those who want to know what is Hue, Hue stands for Hadoop User Experience, which is a beautiful UI. Instead of learning any Unix commands or Hadoop commands, you can use the UI to upload the data, download the data, etc., etc. I will never ever be telling that. Just for your information, I told you. I don't want to use UI. Hadoop User Interface. This is the link. Hue. Okay, please click on Hue. This is the link. It is there in front of you. Right?
Yeah.
If you want to log in, please write down somewhere in your notes. The username and password is Cloudera, I think. Please type Cloudera, username, and password is also Cloudera. It should log in. I'm not sure, but I don't use it. So just copy Cloudera and see whether it is working or not.
Yes, it's working.
Okay. That is the Hadoop user interface. Once you get professionals, once you become big Hadoop engineers, at the time you use Hue. But please don't ever open that Hue here. Hue is for easy usage. Okay. And another thing, it is Cloudera who is propagating Hue everywhere. So somewhere if you go to a Hadoop based environment which is Mapper or Pivotal or Hortonworks, Hue might not be available, you will be in trouble. So don't rely much. I remember what I told you yesterday. I'm not going to teach you anything which is proprietary.
So, can I call? Can I call?
Yeah, please. I'm waiting. And please share your screen. And you don't mute, you mute and you reduce your volume. All right. And I want you to show me that virtual machine where you have opened the browser. And please look at the screen. Click on the terminal. And now please do these things, okay? Means I'm also getting old. Why? Because that is why I cannot see this much small letters. So please go to edit. Please go to profile preferences. Look, and follow what I'm doing. Don't ask me later. And go to this particular one, uncheck it, and then increase this particular font, and then make sure that it is around 20 or 22, so that you clearly see and you learn whatever is being typed, and then close it. You see how nice it is. Okay, these are all not somebody will tell you. Just to look at the settings on the top terminal. Go to the edit. Go to the preferences. Change the font. Right, and everything is very, very clear now. Okay. Once you are there, okay. But I need a chair. You may use. Oh, okay. Just pass.
I can take the.
Okay. Seiko, can you please share the chair? You keep your back here. Oh, okay. It's, Okay, now everybody is in this particular loop, and please listen. Bhaskar was complaining in the morning, I am typing the command, nothing is working and all those things,
So
right?
you want to?
Yeah, I will use this, no problem, okay? Just for some time only.
Okay.
And now please listen. Look at the diagram. What did I do? The controller did. The controller took the data and put it into HDFS. So this data is available where? Is it already in HDFS or outside? Common sense. Is it inside HDFS or outside? Outside, yeah. Outside, right? So if something is outside in our technology world, what is that outside?
Local system.
In the virtual machine local system.
Yeah.
Local system, forget. Your computer is virtual machine. So outside the HDFS means in the virtual machine's local system, right? Okay, so what you are going to do now? That chunk of data we are going to create. So please look the command. And I am going to type the Unix command. Hello, look here. vi input.txt. What is vi? Is a Unix command. And I am not going to spend time on that. We already told you. vi input.txt. I am going to create an input data, and please look at the diagram. The controller is creating the data outside. And in that input data, I am going to type my data. And my data, all of you did it that. Twinkle, twinkle, little star, how I, what you are. Don't worry about spelling test. This is not English test. How I wonder what you are. And now escape, shift, CZ. This is what I told you that. You'll ask me what is the key you press to come out. Unix commands. Escape, shift, ZZ. Or colon WQ factorial. I leave it to you. So I created input.txt. And now what did you create it? Please map. What did you do? What did you do? Chunk of data outside. What is the next step? That input.txt I am going to take and I am putting into trucks, which is the data node. This is where HDFS commands are coming in. What is the most commonly used Unix command for putting the data? Put. If you know Unix commands, you already know Hadoop commands. For example, what is ls?
Listing the directories and files.
It is listing all the directories and files of your local system. Correct? Local file system. Okay? What I am going to do? Use the arrow key. Again, don't type, because in Unix, if you use the arrow key, it will show you the previous command. Just to go to the beginning and please by heart these two words, like Om Namah Shivaya, sorry, Indian mythology. Puja. Just by heart the two words. What are the two words? Hadoop space FS. And then put a minus. It became a Hadoop command now. You understand now? But please don't say the whole world of Unix commands and don't put Hadoop FS in the beginning of it. No, it is not going to work. There are some commands they have given to you. Okay. So Hadoop FS minus ls. What it will tell you? What ls told you? ls told you the local file system. What Hadoop FS minus ls will tell you? It will show you the HDFS file system. So let us see what is there inside. Press enter. Blank. Why is blank? I had trucks are empty. You didn't put anything.
No, it has 3 files.
That is why is it here? Oh, friend. Hadoop FS man. Don't worry. Don't compare with that. New. Hadoop FS. I know you are told. FS minus ls. Nothing is there. So what I am going to do now? Put the file. And which file I am going to put? But there is a problem. In Hadoop, you cannot just put it. You have to create the truck first to put it. And how are you going to create the truck? Truck is nothing but a directory. How will you create a directory? In your Unix, mkdir. And what is today's date? Let us create it as September 9. 8. But don't type enter. What is mkdir September 8 will do? It will create in the local system. What do you need to do if you want in Hadoop? Hadoop FS minus mkdir September 8. It created a directory in the Hadoop and see what is happening. And can you guess what is happening? Now somebody is doing so much work when you type it. Huh? This is taking half an hour because it is Vara's computer. It won't take. You need a microscope. That's why I told you to make it big.
Yeah, I'm getting name node
So,
cannot create.
if the prompt is coming back, everything is fantastic. Now you created a directory inside the Hadoop. And there is something else also happened. The name node took all the details and told that, okay, there is a directory now existing. The ledger is created in the background, which you don't know. You created. If anybody got any error, any other message, name node is in safe mode. Okay, his she got corrupted. This is what I told you. It's something wrong. Whenever you got that particular message that your name node is in safe mode, type an administrative command to tell the name node to never to be in safe mode. So please type only you. Hadoop DFS admin. DFS admin. Single word. Space. Safe mode. Space. Minus leave. Minus leave, single word. LEAVE. And press enter. What did you get? Let me check whether the command is correct. You got so many errors.
Syntax error.
So type the syntax error. Did you type correctly?
Yeah, Hadoop HDFS admin single safe mode.
See, this is where you have to start applying common sense. What it is telling?
Hyphen safe mode.
So it should be Hadoop DFS admin hyphen safe mode leave. No hyphen for leave. Okay? Okay, and please share that command to everybody. What is the command? Hadoop
Hadoop DFS admin
DFS admin single word
hyphen safe mode
leave. And please write this in your notes. Okay, this is what the difference is. When you do, then you will know. And don't type that if it is going safe mode only. Okay, and after you do that, now can you create the directory? And it should work perfectly now. Alright, you created the directory and now it is the time to move that thing from your local file system to the trucks. How will you do that? Hadoop
But it's in this.
fs minus put. Input.txt is the file that you are going to do or you created, and you are going to put it into September 8 directory. So you are moving the file into the truck. Look at that diagram.
But the terminal's already in the virtual machine.
Pardon?
The terminal's already inside the virtual machine.
Of course, I am working
So
completely on
Hadoop is inside of the.
Yes,
virtual
of
machine.
course.
Okay.
It is not in the local, right?
Right.
Virtual machine is containing everything. Right? And press enter. So many things are happening now. The name node is creating the ledger. It is dividing the data into blocks. Your data is very small, so there is no block, only one block. And that is getting put into September 8 directory. You executed the first Hadoop command. This is how you should practice all your Hadoop commands. Bhaskar, what did you make a mistake?
I tried directly.
You tried directly. So now you understood the difference between local file system and the Hadoop file system.
I used the copy.
So you created the file and you put it into that particular directory and you created it. And can I do one more time? And press enter. And you will see that it is failing. And it will fail with a common sense message. And the message is September 8.
Already exists.
File exists.
And the next important thing outside the class is always make sure you read the error messages. Just like what I told you to Ravi now. That hyphen safe mode is clearly written. You don't need anything else if you make a mistake in your commands.
What if you wanted to override it? Could you do that?
Beautiful question. So if you want to overwrite it, What you will do in Unix? Psycho? Force. And you should not get any error. It will overwrite that particular file because you are forcing it. In the similar way, if you want to, okay, whenever you are writing the file, please listen here. It will be written as the current date, even though input.txt you created 5 years back. It will be written to here as of now. If you want to preserve the date of that input.txt 5 years back, also into Hadoop, use an option -p, which is preserve.
That's like the SCP.
Yeah, absolutely. You created that particular file and you created the first directory. And now can you do a Hadoop fs -ls? Use arrow keys because you already typed that command sometime later. Hadoop fs -ls and press enter. Whenever you are doing this, now you will see that there is a September 8 coming in, which indicates that your HDFS is filled. One truck you got filled. How many duplicate copies of this data is created? No. Why? Anybody? You are in the virtual machine. I told you that you have got one name node and one data node. How can it create 3 copies? In the same data node, it will never create a copy. That is for the professional Hadoop environment. The difference between that professional environment and your virtual machine is that in virtual machine, replication factor is 1. Whereas in the real default Hadoop cluster, it is 3. So here, if it is gone, it's gone. Alright, now I want to print the file inside this September 8. How will I do that? There is a Unix command which is cat, and I am going to use that command, Hadoop fs -cat, and I am going to write September 8, and you already know inside the September 8 there is a file called input.txt, and if you press enter, it is now going to show you the data that you put inside the Hadoop file system. So clearly understand, this is coming from Hadoop file system. If you simply write cat input.txt, it will come from your local file system. Local file system is this. Hadoop file system is this.
Local is really the virtual machine.
Yes, virtual machines, local operating system, which is Linux. This is HDFS, is what I'm saying.
Okay.
That's the difference between.
So local, this is a Windows, so.
Array, Windows is completely different.
Right.
You forget about Windows. Local file system
Right,
means.
but the virtual machine is Linux.
Yes. Forget about Windows. Consider your virtual machine as a computer.
Right.
That virtual machine is a Linux computer. In that Linux, local file system is where the normal Unix commands will work.
But then inside of that is a Hadoop.
Yes. What should I do now to tell you?
I have a question.
Again, you are asking that same question again and again. Okay. This is Windows. Inside the Windows, you have a computer, which is the virtual machine, which is Linux. Inside this, you have got Hadoop. When I write input.txt, first I wrote it inside the Linux. Then I moved it inside the Hadoop. Then I printed it from the Hadoop. Is that clear? Psycho? This is for you.
Yeah, I'm just
Yeah. What is the question?
When we use this Hadoop FS, whatever the commands, right? Happen and all after Hadoop, if you use all any Unix command we can use, or only few certain.
What did I tell you just some time back? If you are tomorrow coming and telling that every Unix command, if you are applying Hadoop FS, it will not work, right?
So
There are most of the commands. So the complete exercise for this week is open the browser, maybe local file system or something. This is for learning. So not open the file system or not open the browser of your virtual machine. Just open the browser. Type Hadoop fs shell commands. Write it down. Hadoop fs shell commands and press enter. And please click on the first hit. And please maximize that. Spend all your time. So you will see just about 25 to 30 Unix commands are available. That's all. You cannot work on each and everything. There is ls, there is put, get, cat, cp, move. There is a restricted set of commands which they have taken from the Unix file system and created a wrapper which will work for the Hadoop file system. It is not all. So spend your time, and no need to be perfect in each and every command. Just to know, see, Albert Einstein once told information is of two types. One is know by yourself, otherwise know where you can get that information. So we have Google. So every time we can get information, whatever we want. So please don't by heart. Whenever you want to learn some command, you just Google it and then find out and then use it. That's all. That's how it should work. Now, if you want to know how the hue works, Bhaskar, can you please go to that hue now? The browser. Please look at the system. Go to hue. Here. Here. Look at my finger.
That's a favorite part.
And please click after logging in. Can you log in? No, it will take half an hour. You told you will bring me a new laptop. Where is it?
No, I upgraded to 16.
What then? Why? You to stop the startup process then.
No, it's already closed. Yeah, I closed all the phones.
You didn't get that one.
It should not take this much time. It's already came. Okay.
Which one?
Hue. Yeah.
You were gonna buy that.
You didn't see that hue? Okay. So about hue, did you log in already?
Yeah.
Okay. So please look at that. This is zoom it. Just go here and then just I'm going to zoom it. I think you can now see it clearly.
Yeah.
And now go to data browsers. No. I'm finding out. I never use this one. I'm just telling you for your purpose. Close, search, security.
This one.
File browser. Here. Click on file browser. And inside the file browser, did you see September 8?
Yes.
And inside the September 8, did you see the input.txt? This is your Hadoop file system browser. And this is what Hue will provide you. Look at that. You have the data. So you can use either the Hue if you want, but please don't rely much on Hue. The reason is if you are relying much on Hue, then you will be tied with a particular vendor. It's not part of the pure Hadoop distributions. You can use if you want. All right. And now a simple exercise. Can you please go back to the terminal? It is minimized. Just click on that. It will be available below left. Below left, there is a terminal. Yeah. Can you please delete? What is the command that you are going to write if you want to delete? Hadoop space fs minus or hyphen rmr recursively remove space September 8 SCP8 and press enter. It will delete the whole directory and the files from the Hadoop file system. Look at that. Deleted the files. and it will be removed from that file system as well. So this is what is the basic HDFS is all about. So if you are coming back to the PowerPoint presentation, you will see that most of these things we have done. I'm just going very quickly. Look at this. It is written 64 MB or 128 MB. This is little old. There is no 64 MB now. From Hadoop 3 onwards, the default block size is 128 MB. Older versions are 64 MB. Okay? I can. So, please look at the next important point. HDFS performs best with modest number of large files. See, it's a very, very important point. What is meant by modest number of large files? Millions rather than billions. Each typically 100 MB or more. Huh? Details is very fantastic when you know the details, and inside you go deeper and deeper. Look at this problem. Assume that I have 1 billion files, each of 1 megabytes. How many blocks will be created? How many blocks will be created? 1 billion files of 1 MB each. Okay, let me ask in a different way. You might be calculating in mathematics, so I don't want you to ask a mathematics question. So let me ask a simple question first. 128 files, each of 1 MB. How many blocks will be created? Interview question. Come on. Wrong. 128 blocks. You understand?
Yeah,
It will be 128 blocks.
each
So
file will have a block no matter what.
absolutely, right? If the file is 128 MB, one file is 128 MB, what you told is correct. 1 block. So now tell me, 1 billion files of 1 MB each, how many blocks will be there? 1 billion blocks. And assume that you are writing the processing on the top of 1 billion blocks. What a worst execution time you are going to get. Your Hadoop cluster is going to sit down. No. And that's what is happening everywhere. Every week that is happening. I told 100,000 times how to correct it. Yeah. There is a beautiful option that is available where you will combine it, zip it, make it as 128 MB blocks so that drastically your processing time reduces and you get efficiency in your Hadoop cluster. So, Hadoop is not good for billions of small files. It is good for millions of moderately big files. You understand what does it mean? It's a very important line. HDFS is write once. Next very important thing. What is the difference between an Oltp system and an Olap system? What is Oltp? Online transaction processing. RDBMS is Oltp. I have $100 in my account. I took $10 out and I took $20 out. Immediately, consistent atomicity, consistency, isolation, and durability. It should immediately be reflected. Otherwise, either the bank will be in problem or I will be in problem. Hadoop, try to write and try to update it. No, Hadoop is not meant for that. So never use Hadoop for taking your bank transactions. Hadoop is for analytics, online analytical processing. Analytics means it is on batch data. It is write once, read many times, not write many times and read many times like an Oltp. That's why if somebody is telling that I'm going to change my Oracle into Hadoop cluster, that is the foolest statement that anybody can make. RDBMS can never ever be replaced. EF code rules 1960 onwards, stable, secure, scalable. Cannot even compare the performance of Oracle or MySQL to Hadoop. That's for a different purpose. This is for different purpose. If suppose you are writing all the last 10 years of your credit bank transaction history once into Hadoop. Then create the behavior of Bhaskar. Bhaskar likes Japanese food because always his history shows that he goes to Japanese food. That is where Hadoop is. It's for online analytical processing. HDFS cannot read randomly. I cannot go to the 100th row and read it. Oh, RDBMS can. Indexed data. That's what this is saying. Files are split, data is distributed, and we have already covered. Blocks are replicated across multiple machines called data nodes. The master node called name node keep track of which block and where the blocks are located. That is called metadata, it is called ledger, it is called FS image. There are different words for that. This is the diagram that you all did in the last class, and today I explained again with a truck example. The main data, this is the chunk of data, twinkle little star, that is getting distributed into blocks. Each block, block 001, 1, 2, and block 0013, 3 copies. So everywhere you will see that there are copies created. So block 001, block 001, block 001, 003, 003, and then 003. 3 copies. In the normal one. In the virtual machine, only one. Why? Only one data node. The name node must run all the time. So what will happen in a Hadoop cluster, a very big cluster, Hadoop name node went down, gone. There is no way that you can come out. That's why in the modern Hadoop architectures, the name node has got a backup called a secondary name node. And that secondary name node in the earlier versions was active passive, which means that the administrator has to restart it manually. But now, if the name node goes down, automatically the secondary name node will come up. That's called active. If you know the data center replication, then you will know the words. Right. Very important point, next one. 128 MB blocks, that is correct. But if there is 1 MB file, the remaining blocks will be reused by other files. Unlike Windows or Unix, where if the block is allocated, even if there is space left, you cannot reuse it. Hadoop is efficient in that. Blocks are stored as standard files. Without the metadata on the name node, there is no way to access the HDFS cluster. Who maintains everything? Any hit when you write that command, Hadoop fs minus put or Hadoop fs minus cat, who receives that command? Name node. The name node will receive, okay, this guy is asking for September 8 / input.txt. Where is that input.txt? It is in this block. Okay, bring it. So, name node does everything. When a client application wants to read a file, it communicates with the name node. It then communicates directly with the data node, and name node will not be a bottleneck. What a beautiful architecture again. Please look at this. In the olden days, if this is the client and this is your application, and application is connecting to the database, you query. Application will query the database. Application will bring the data. Application will give to the client. Every time. What will happen in Hadoop? Client will ask the name node. This is the name node. Name node will tell where the block is, and once the block is known, it will go here and it will bring the data. Name node is not a bottleneck. And name node stores that metadata in the RAM. I already told you. So there is no disk input and output. So fast, very fast. Everything in big data is about distribution, network bandwidth, fast.
But how much RAM do you need for that?
Very big. It will be in gigabytes and terabytes. Name node will be the best computer that is available on your cluster. And data nodes will be called as commodity machines, which are not that powerful. Also, that's a very good question, that if you look at the architecture diagrams, if this is the name node and if these are the data nodes, the data node will have a lower bandwidth of, let us say, 1 gigabytes per second or something between them. Whereas, if you look at the line between the name node and the data node, this will be 10 gigabytes per second line. The reason is name node manages more communication. than the data nodes. That's about hardware, don't worry. Accessing HDFS, FS command. These are some examples of the FS command. We have done some of them. Please practice. Next class we will look MapReduce. How to do the processing and computation on the top of that. And you will learn Java.
Everything explain that one, like how the communication goes from client to.
Okay, you are logging into Bank of America website and you logged in and you wanted to get your credit card. What this Bank of America application will do? It will go to the database. It will bring the data. Then it will give you. So always, who is the bottleneck? Application server. Now, replace this with a name node and ask the name node, where is the data? Name node told that the data is in these nodes. Then you don't need a name node. You will directly go to the.
So how the communication will come back to the client or something like this? His name node says.
You asked the name node, where is the data?
Okay.
Where is our slip, man? You asked the name node, where is the data? So, first copy is there and name node told me that the second copy is in Bhaskar. Now, is there any need of name node? Are you understanding? I will directly come to you and I will ask you. So, there is no bottleneck for the name node. Clear? So, please practice, start reading the O'Reilly book. Now you will understand. Because I gave you the complete overview of what is happening. Right? Shut down the virtual machine. Make sure power is off. I will send this video. The complete lecture is there already.